Well, hello everybody. Good morning, good afternoon, good evening, good night to everyone wherever you may be across our lovely world. Thanks so much for joining us live today for Serverless Office Hours, streaming on the AWS Twitch channel, on YouTube, Serverless Land, and LinkedIn.com. What a motley crew we have joined with us today. Isn't this awesome? The band is sort of back together. Well, most of the band, how about that? I think that is absolutely awesome. What I'm going to add onto my screen, because I just want to tell people who everybody is, because it's chaos, everything's going mad. Welcome. We've got developer advocates galore on the stream today. Welcome, Ben, Dave, and Eric. Ben, welcome to Office Hours yet again. What are we all doing together? How's your New Year been, Ben?
Super. Yeah, I was in Japan doing some skiing for New Year's.
Terrible. Sounds terrible.
Awful. Yeah, horrible time.
Cool. Eric, welcome back. Like the host extraordinaire of Office Hours as well. How is life with you?
Life is good. I can attest to Ben skiing because while I was working, he sent me videos of him skiing. So really tight friendship. Took a bit of a beating there. So yeah, but great New Year's. Great to be back. Good to be talking serverless. So here we go.
Cool. And Dave, welcome to 2024. What were the major events that you enjoyed over your holiday?
Well, I was not skiing. Thank you for inviting me. I was not skiing and I was not working actually. So I had a good time off, good break. Saw Santa Claus about 3 times with my kids. So it's probably my best event there.
Fantastic. I like the way that you've peaked, I think. Santa Claus, yeah, 3 times. That sounds perfect. So we've got all of our contact details over here. Happy to get in touch on everything. But today is a little bit of a slightly different, chaotically awesome show. And what we're going to start is we're actually talking about an app called ServerlessVideo. Now, I'm going to put the link on the screen because this is play along at home as well. So if you go to video.serverlessland.com, on the screen, we would love you to watch us live on ServerlessVideo, and we're going to dive deep into how it all works. But head over to video.serverlessland.com with one ear on the stream that you can keep going, just so you can log in and get going. So when you join us for all the fun and games, you've done that because, it takes 1 minute and you need to remember your email address and all that kind of thing. While you are doing that, let's just remind you of the other kind of things that are available on our Serverless Land YouTube channel. Last week, not last year even, we can say, on the 21st of December, we did a 2023 year in review, and we had a whole bunch of people who were talking about super cool things that we did, and feature releases and everything. Apologies, Andre and Kensuke weren't actually on there. I don't know why I didn't edit that, but anyway, that's why we're obviously taking the start in the new year a little bit slow with names. But yeah, plenty of stuff we talked about with some of our awesome specialist service solutions architects, talking about all the things in 2023. So have a look at that for that episode and all other Serverless Office Hours episodes which are on Serverless Land. I'm talking about Serverless Land at serverlessland.com. That's where everything to do about serverless on AWS, and we're obviously going to be talking about that with ServerlessVideo. So jumping over, hopefully you've done your logins and everything. Dave, should I jump over to you? Like, what is ServerlessVideo?
Great, yeah. So I've got some slides here actually to help kind of visualize what I'm talking about. ServerlessVideo is actually a kind of visual application.
Cool.
But it's kind
Dave, are your slides shared? Because we just there we go.
Yeah.
Perfect.
Cool.
Yeah, and of course, before Dave goes on his awesome kind of stuff, let me make sure you can see him as well. Remember, we are live on Serverless Office Hours, so send us your questions, your comments. Tell us where you're from. Tell us how many times you saw Santa Claus. If that is Father Christmas, if that is the thing you celebrate, if there are other things you celebrate, hope you had a good time. Tell us what you're most excited about in 2024. Any kind of thing, we'd love to hear from you and let us know what you're doing. Dave, back to you.
Cool, thank you. You can see the screen okay, yeah?
Yeah, we can see you great. Eric's in front of me, but I'll move him out the way quickly.
Okay, so ServerlessVideo, what is it? So ServerlessVideo is an application that we built as a DA team to showcase serverless technology. It's a full stack application, and we initially launched it at reInvent, actually just gone by. And it's a video streaming application that you can use to broadcast videos, and you can connect, and people can connect and watch videos. And they can do all sorts of things, and it's all built on a serverless kind of event-driven application actually. So as Julia mentioned, you can go to video.serverlessland.com to see it in action, and we're going to be doing a demo in a minute to actually we're going to broadcast some things live. So if it'd be cool to see it in action. But equally, this is how it works. So we have videos on demand that get processed using step functions. We have Lambda, we have ECS, all sorts of stuff I'm sure we're going to be diving into. But this is how it works. So we log in, broadcaster would log in, and they start broadcasting some content. And as it's broadcasting, we use services like IVS to be able to, which is an Amazon service, to handle the streaming. It's actually technology that is used on Twitch.
So
And
then, IVS, it's an acronym. What does that mean? It's early in 2024. Have you been doing your memory and your research so people can find IVS?
Yeah, so if you do Amazon IVS, I think it's interactive video service.
Oh, there we go. Dave's got it. Yeah, that's 1 point for Dave. That's one emoji for Dave.
Yeah. So broadcasters can broadcast live. So as you're broadcasting, you got these emojis coming in. We use API Gateway, SQS, we use Lambda for all this stuff. And then you can watch and interact with people. So we can talk about at reInvent, we were interviewing customers, talking to people, talking about all the serverless technology, all new announcements that we saw at reInvent. And then equally on the right-hand side, what happens is all the videos are played back on demand. So as they're played back on demand, it goes through a very interesting architecture where it's all about plugins. And we use Bedrock for title generation. We use Transcribe to get the transcriptions off videos and all sorts of things we're going to be diving into later. To give you some overview here, so we use generative AI. So we use Bedrock and Transcribe to as I mentioned earlier, to generate them titles. Plugin architecture. So we use an interesting plugin architecture that we actually built to allow other people at AWS to actually contribute their ideas and their plugins into this ecosystem, right? So based on events, based on their code, they can actually say, okay, well, I want to transcribe the video, or I want to use Adobe, for example, to take the thumbnail and generate a new thumbnail with some magical stuff on that. And then equally, we've got this serverless compute. So we depending on the length of the video, we use Lambda or we use ECS. And again, we'll probably be talking about that later. But to show you it in action, I think this is what we're waiting for. What we're going to actually give you a quick demo. Right, so I believe myself, Eric, and Ben are going to do some broadcasting. So if you're on the app, give us some emojis, and maybe Julian, you can kind of walk people through that as we're doing.
Yeah, definitely. So, well, all three of you can start broadcasting. You can see Ben has got his phone, and he's literally, in fact, Ben, if you hold up your phone to the screen, there's a sort of get permissions, and let me switch over that. And basically, what's going to happen is all three of our lovely DAs are going to be broadcasting themselves on serverless video, and I am now then sharing my screen. So they've gone mute on the stream because they're not quite on the screen. Oh, shock horror! Eric has bounced back, and he's showing around an office where he is. And yeah, we're all in offices. So Ben's up there as well, and you should see Dave should be joining soon. So one of these kind of cool things is you can have multiple people that are actually broadcasting at the same time. So you can imagine being at an event or a sort of a Twitch style or TikTok kind of style where multiple people are broadcasting at the same time and people can interact with separate videos. So we've got hello everyone. Look, who's coming over here. We've got Ben who's actually coming over here. We've got all three of them. So that's the home screen. So if I go into Dave, for example, I should have gone into Ben.
Yeah.
Dave is talking. Now, I can't talk today.
We've done the demo of this at reInvent. So we're actually interviewing loads of different people, which is pretty cool. So you can actually watch all these videos on demand on ServerlessVideo. So if you weren't at reInvent, or you didn't see the stuff that we were talking about, you can go back and look at all this stuff.
Cool. So that was a bit of Dave. Let's see who else is still going. Ben's having a walk around an office as well. Yeah, Ben,
looking directly.
So we've just jumped into Ben's stream. What's he talking about?
Another office. Lovely, lovely. We'll complete the tour. Further walk round. Better not show any screens in case there's some top secret work going on.
All you can see over there while Ben is chatting, as well as you can interact, send some emojis.
Original desk as I move cautiously around the London office. I believe this is where I was sitting. Let's check. Yes, I'm back. That's me. Right, let's hang up.
Cool. Well, so we've sort of seen a bit of a whistle-stop tour. We didn't actually see too much of Eric, unfortunately, even though Eric's obviously the most important. Is Eric still broadcasting? Let's go and see if, Eric is broadcasting. Let's get Eric back on. We need to give Eric some love, of course.
I'm broadcasting now. Yes, I am broadcasting right now. I noticed that you left me out, so I added myself back into the stream because, come on, I need to be in there. So I don't know if you can see my soul or not, but there it is. So
Eric's got a great soul.
I'm going to turn it back over to Julian.
And you can see while Eric is on, we can also
be a great day.
sending lots of emojis. So yeah, I'm sort of slightly talking of Eric, but we've got lots of emojis.
I don't have real thumbs, but look at all those thumbs.
Oh yeah,
up. That's pretty cool.
Come on, join us on the stream and give Eric some extra thumbs.
That's right. That's awesome.
Hopefully up thumbs, not just down thumbs.
Everybody needs thumbs. That's right. That's right.
So,
all right, we'll see you later. Bye-bye.
Cool. So basically, we've now been watching to see how different people can broadcast. And obviously, when you're watching, I don't think you're going to be jumping around to, multiple broadcasts, but you can see what it is and the whole sort of cool architecture that's happening. So that's the live portion of this application. And remember, as Dave lined us up, this is all about showing how you can use a serverless architecture to build a video streaming application. But also remember, even if you don't really want to build a serverless video application where you're doing it, a lot of the things and architecture patterns are applicable to any of your kind of workloads. And this is what we're sort of going to go into now. So we've done the live part of it, but Ben, some stuff is now happening behind the scenes. Why don't you walk us through what's going on?
Yes, I've finished giving Eric some extra thumbs. That was good. You got my screen up on share. Lovely.
I think we've peaked in office hours when the remit of the show is giving Eric some extra thumbs.
Yeah, that was like video section when I walked in on you while live streaming, while you live streaming my live stream. Sorry about that.
Mind-boggling. Love it.
Okay,
very few people can follow that.
I want to talk about what's happening right now in this AWS account that's hosting ServerlessVideo, because there's a bunch of things that are currently running now that we've all finished our stream. And the first thing that's running is this step functions workflow here, which is responsible for converting multiple TS streaming files. They're each about 8 seconds long, pushing all of those TS files for each individual stream into one longer MP4 file. And
so the TS files, is that what IVS creates? So IVS is, that's the sort of copy of the live broadcast.
All the while that we're streaming, IVS is saving these segmented TS files of about 8 seconds. It's throwing them directly into an S3 bucket in real time, right? And then that's what you're able to then play back on demand at various different qualities, different rates. So what we want to do, though, is we want to generate an MP4 file so that we can pass an MP4 file to various plugins, as Dave mentioned earlier, to extend the functionality of ServerlessVideo. And I'll show some of the plugins that we've built in just a moment. But the first problem that we faced when we were building this is, how can we create these MP4 files? And we tried a few different things on this journey to building this little microservice. Where we landed ultimately was this workflow here. And I want to talk about why we got to this workflow. So originally what we had was a Lambda function that was using FFmpeg, which is a library for interacting with media files. And we were using this Lambda function to generate this MP4 file. And it was working pretty well for most use cases as we were testing this application out, as we were building. But we started to record longer and longer videos as our application became more and more robust. And eventually we realized that when we did a longer video stream of 15, 20, 30, 40 minutes, our Lambda function was hitting its 15-minute timeout because it needed more time to process hundreds and hundreds of TS files into an MP4 file. So we kind of went back to the drawing board, and what we built initially was a workflow that would catch that Lambda error. We would take that Lambda code and we would spin up an ECS Fargate task, exactly the same code, run that in Fargate, which doesn't have this timeout limitation, and it would produce the same result, which is ultimately creating an MP4 file. We then went a step further. After more testing, we realized there's a sweet spot where the Lambda function starts to time out, and that was with videos that were about 20 minutes in length. So we preemptively orchestrate which one of these compute substrates we want to use to convert our TS files into an MP4 file. So if our video is more than 20 minutes, we're going to go straight ahead and run that as an ECS Fargate task. And if it's less than 20 minutes, then Lambda will be able to run that and convert that very quickly without timing out.
So Ben, why would we not just use ECS for it all. If there's a time limit that we're going to bump up against, why not just use ECS every time?
Well, it was actually quicker to use Lambda for the smaller workloads, which is about 90% of all the videos that we were creating on serverless video were very short files, very short streams of about 2 to 5 minutes. And it was much faster to quickly spin up and deprovision Lambda functions without having to think about all the different things involved with that, right? So the majority of our workload still goes through Lambda, but we have a fallback or a decision where we can run those longer files as an ECS Fargate task.
And then you also mentioned that it's the same code. So, I mean, running the same code on ECS and ECS Fargate and running the same code on Lambda, I mean, that sounds cool. How does that work? Because there's a good portability and you're not having to make a hard choice there.
Well, this wasn't really an issue, actually. There's a tiny difference in the code, and you can see that on this slide here, with that our Lambda function has to include our exports handler. And we could probably have gone even further and made it so that there's exactly the same code. But what we decided was this was a reasonable compromise, right? Was to have this exports handler in our Lambda function, whereas in our ECS Fargate task, it was just an asynchronous script function that we would run called main, right? So that's the only difference in the actual code that's running in Node.js. I want to talk about what happens after that MP4 file gets created, right? So that MP4 file was saved in an S3 bucket, and then this workflow finishes and it emits an event onto our serverless event bus using EventBridge. That event is then sent on to various plugins. And we have plugins that do all sorts of interesting things, plugins that generate titles. We have plugins that transcribe the speech in every video, plugins that translate that transcription. We have things for leaderboards, things for content moderation, multiple plugins that we run through this workflow once we've generated this MP4 file. And the way we built that, because we didn't know what plugins we would be building in the future, but we wanted a way of being able to cater for multiple different plugins well into the future, regardless of what those plugins do, and to be able to kind of onboard new plugins without the application breaking what's already running. And we came
so is this also sorry to jump in again, Ben, but is this some of the sort of evolutionary architecture or a plugin architecture? I'm just trying to think about how this would be applicable in other examples, because anyone writing an app doesn't necessarily know what future functionality is going to be. How would the architecture that we've used here for the plugin architecture for serverless video be applicable to evolving another application that you may be building yourself?
Well, it's just based on events. So we make sure that every microservice or every plugin in this case is completely decoupled from the core application, right? So all it knows about is the event that it has to consume. And we have a separate microservice which is producing those events, and all of our plugins know how to consume that event and what to do with it and what to return back. And really, we did this on purpose because we wanted various experts that were speaking at AWS reInvent to be able to go crazy with the different plugins that they could build. We really didn't know what to expect. But what we did know is that we would probably need a kind of order that we wanted these plugins to run. So we created an artificial, what we call an event hook, which we orchestrate using a step functions workflow. So once that MP4 file is available, this step functions workflow starts. And the first thing it does is to create and emit this new pre-validate event. And here we asked our plugin developers to build plugins that would moderate the video that's just been broadcast, make sure it was more than 5 seconds long, make sure there was no inappropriate visuals in that video, things like that. And they would register for that particular hook, the pre-validate event hook. Then all the responses, our workflow would wait for all those plugins to run. And then when they respond back with their payload, that payload would be sent in to the next event hook, which was the post-validate event. And here we asked our plugin developers to build things for reporting and internal notifications. And again, the application waits for those responses, and then it emits the pre-metadata event. And this is where it gets really interesting what our plugins are doing, because they're doing things like generating titles and tags and filters and leaderboards and transcripts. And all of that data is then passed back to the final event hook, which is the post-metadata event.
So this is the reason you need to have some timing orchestration, because for example, if you're going to transcribe the video, you need the audio files obviously available.
Yes.
If you're going to transcribe it and then generate a title based on the transcription, obviously the transcription needs to happen first. And so is that the sort of, ordering? And even though you say the artificial hooks, but that ordering is important because, certain plugins need to run after each other.
Exactly. If we had just said, here's, our transcription is finished, here's a bunch of plugins, all those plugins emit events when they're done, it would be very difficult for us to make sure that something is finished before something else is supposed to run, and to monitor and track all of that would have been difficult. So that's why I suppose
if you think of it, another solution, if you were using event bridge rules, for example, then each, if each plugin finished and just submitted an event bridge rule, the next plugin would have to pick that up, but you would have to sort of change the ordering of every single plugin to be able to, every time you added a new plugin, you'd have to rejig all of the rules.
Yeah.
I mean, and that just sounds like a nightmare. I mean, super good friend of all the serverless, Grant Lammy. Thanks for joining us, Grant. Awesome to have you via YouTube. And we were talking about the message popped up when we were talking about the pluggability. This decoupling makes it easy to extend. Even something is regulated as a health clinical thing. And definitely there's Grant's been doing a whole bunch of work at EDA event-driven applications, Architecture's Day in Nashville. Grant did a talk, and actually in reInvent, if you search SVS 205, I seem to think, but it's basically Halim Mesrobian, one of the big bosses of serverless, and James Bezic and Grant Lammy talked all about using serverless in a heavily regulated environment, a medical environment, and doing some great things with it. So Grant, thanks for chiming in. We appreciate getting your take, because this isn't just applicable for a fun little demo application that we're building here. It's like literally helping to cure kids with cancer. So that is awesome.
Grant is one of the true step functions geniuses.
Gurus.
If you ever want to learn step functions, Grant's giving free class. No, I can't say that, but he really is. He has done some amazing thing, and he kind of sets the standards for best practices for step functions where he is, and a lot of other places. So super smart guy and a great hairdo. So it works out.
Ben. Sorry, we did derail a bit, but let's get you back on track.
Sure. So I'll show you an example of a pre-validate plugin, which is our content moderation plugin, which uses Amazon recognition to make sure there's no inappropriate imagery in these videos that go out, right? So this is what happens. An event payload gets emitted onto our event bridge event bus that says this is the pre-validate event hook. And this event payload is routed to this moderation plugin. The plugin runs, it will return if this video is valid true or valid false. Let's say it's valid true. That will then return an event back to our event bridge bus, where we have a router or a rule that will route that event to a Lambda function, which will finally return that to our step functions workflow to say, here's the result of that moderation plugin. And therefore, we know this video is safe, and you can go on and go ahead and run the other plugins. Further on, down the event hook lifecycle, we have another plugin which will transcribe our workflow using Amazon Transcribe. So it will work out what was said in the video. The payload of that is saved in S3, and a pointer to that payload is returned back to the workflow. And the final plugin that runs is this Bedrock plugin, or plugin that uses Bedrock to generate a title based on that transcript, right? And I mean, we've been talking for a long time. It doesn't take very long, but if I go back to ServerlessVideo when we were just streaming, here's our live streams from just now, right? Here's what Dave did, and it's named his video, live stream demo of AWS Video Service, featuring interviews, behind the scenes look at video production. That's all entirely generated by our lifecycle workflow and by Bedrock. You can see as well, we should have some tags here. So it's tagged it live stream, AWS Video Workshop. Here's the transcript. Here's the lovely thumbnails that have been generated by Adobe. Could be call out to Adobe using an integration there as well. So there you can see the end result. It takes moments to appear on our website, and I can play this back and watch it on demand.
Wow, awesome, Ben. Just let's have a look at some of the other titles, because we know what people were talking about. I think one of them is even hilarious. I mean, that's like having fun streaming and chatting. Basically, that sounds like Eric's job description, I think.
That's what I do.
Oh, this is my one. I guess I wasn't in frame when this thumbnail was taken.
No.
But, hilarious office tour and live stream mishap. That's obviously me walking in on you. Brilliant.
There you go.
What we also built, and this is interesting for people who want to dive deeper on this, is this history page, right? So here we have a timestamp of every event as it passed through the system and the different service that it ran into or that it was routed to, and what that service did in the context of serverless video. So every single video will show all the different plugins that were invoked and the responses and the timestamp on when that plugin was run. So it's a really nice way of understanding the flow of each video and all the services that were involved to get this video from live stream to available on demand.
So is this another then microservice that creates this journey, and how's that actually capturing all of this data? Are all of these services individually writing to a database, or how would you construct this?
Well, I could tell you about that, but I could see Dave, the man that built this particular microservice, is keen to explain it. So Dave, why don't you go ahead?
Yeah, it's an interesting one. When we were building this, I remember Serverless Espresso. So this is another app that we built previously, and we have this flow of how your coffee was built, and I remember like that quite a lot. So you can see your step function workflow. You can dive in, and I was thinking, how can we build this for serverless video? And the interesting thing is there's loads of events going on, right? So from when you start broadcasting to when you end, to the plugins, to every single plugin is emitting events. Events are everywhere. And I remember saying to Ben, wouldn't it be cool if we had a history page? So Ben was continuing doing his work, his plugin orchestration stuff. I created a new service on the side, didn't even touch any of the architecture, and just consume the events. Yeah. So I say, give me all the events that are being raised on this event bus and these particular things. So then what I could do is then just store them in DynamoDB. So I'm just a simple event store. So I say, okay, I've got this event. I'm going to store this directly into Dynamo, and then what I can do then on the client through an API is just pull that information back. So I can say, okay, well, I have this information. I think it goes through a Lambda function to add some like metadata on the event, some information. So you can see here we've got like a title and descriptions and things like that based on the events because it needs some context. And that was it really. So it was like a simple way of grabbing all these events and visualizing the events in this particular flow. And I remember showing Ben, and we deployed it. Again, this is the whole cool thing about EDA, is I built it, I deployed it, I tested it without even affecting any of the other architecture. So if this history page goes down and if this isn't working, the whole app will still work. And we built this application with the events and with these features in mind, that if the generate title plugin went down, that's fine. The rest of the app will still work because it's no longer emitting events, but the rest of the app will work. So we kind of built it up in that kind of way, and it was quite resilient. At reInvent, we had no failures on the thing, so it's pretty cool. So then we showed customers this, and yeah, to be honest, I think I enjoy looking at this. I enjoy kind of reading how videos were made, and it's a great visual representation of what is happening behind the scenes. So. Yeah.
So Dave, would you consider this a microservice in itself that is going to react to events and then emit events? I mean, maybe just give us a sense of when you're approaching an application like this and all the great building you've done, how do you even decide what a microservice is and what the sort of bounded context, I suppose, is the bigger question. And yeah, when you're approaching this as a big project to do, yeah, what is your thought process to do some of the designing?
Sure, on this particular feature?
Well, yeah, or even in general. Yeah. I mean, or you can
start with sure. I mean, in general, so this particular feature, as I said, I already knew the events are in the event bus because obviously we've been building the whole thing. So, and I wanted to design this service, as I mentioned, just to be something separate. So that was fair enough, and that worked out quite well. The biggest scale of it, really, we looked at, first of all, we're looking at our video streaming options, and at IVS, we have a service that actually provides decent streaming capabilities for us. It was fantastic. We were like, this is the thing we want to use in our app from that initial inception. But the great thing about IVS and the great thing about a lot of AWS services actually is the first party events, right? And so I remember I was chatting to Ben, and we're like, okay, well, how do we know when a broadcast has started or a broadcast is ended? And these kind of things that we want to find out, because when we start to map this flow on a whiteboard or event storm or any of these things, we have a flow, right? A user will broadcast, the broadcast will end, we want to process it. There's all these particular events and things we want to do. We can visualize that, and we did. But luckily for us, the services IVS in this example provided the event. So that's great. So now we have an event in our architecture we can listen to. Okay, so what do we want to do when a broadcast starts? Well, we want to notify everyone in the world, right, that the broadcast has started. Okay, so what can we do with that? Let's take the event, and then how are you going to notify? How are you going to notify users that broadcast has started? Well, WebSockets is a good example here. What WebSocket technology do we have? You know, we have AppSync. We're using IoT Core here as an example there. So we just kind of, you know, we're going at it in this kind of manner. But yeah, the initial design and the aspects, thinking about the different boundaries, thinking about how you consume events. But the great thing with this architecture in general is remember when we were building it, we were kind of adding features on like this incremental process. So the first thing we've done is a live broadcasting app. Okay, so what's next? Okay, well, what about plugins? Let's build the plugin part. Okay, what's next? And we had this continuous value that we were delivering as we were building this app. And that allowed us equally to, as I mentioned earlier, to handle errors and gracefully handle problems. So if parts of the app don't work anymore, like tagging, or parts of the app don't work, like titles or whatever it is, or even, to be honest, broadcasting, if the whole broadcasting system, for whatever reason, stopped working, the app still runs, right? We have on-demand videos. They're pulling from an API, all this kind of stuff. So, yeah, I think that worked out pretty well for us and allowed us to kind of scale and rapidly build this thing.
Well, thanks, Dave. And in fact, Fane Rob, thanks for joining us via Twitch. So that's the question on your sort of resilience thing Fane Rob was asking earlier. You know, what if a validation plugin would stop working? You know, what breaks on the app or what happens? And I know, Ben, you had some info about sort of what that happens. So either Ben or Dave, what happens and how do you make this application resilient in that way?
This particular question, right? What happens when you fail at the validation hook? We had to have a think about that, because originally we decided that if it fails validation or if it doesn't pass validation, then there's no point running the other plugins and finishing the workflow because it's not a safe, valid video. But then sometimes it would fail or not pass validation, and it would be wrong, right? It would have a low confidence score, but it would, to be safe, not let it through. And what it would mean is that we don't have all the other data about the video because it didn't run through all the other plugins. So even if we were to watch that video and go, oh, actually, this one's okay, we should publish it, well, we don't have all that data to publish. So we changed our minds on that, and we allowed, even if it doesn't pass validation, we allowed it to finish the lifecycle event hook, but not be published. So it would be in a pending state, and it would notify an administrator who would then review it in person, and then we could decide whether we should publish it or not. If any of the other event hooks failed, then we would wait a certain amount of time, 30 seconds for each plugin to complete. And if it didn't complete within 30 seconds or it failed, we would ignore that response and move on, and everything else would, the front end of the application would just fail gracefully. We had ways to like placeholder values for things like that.
Okay, thanks. So yeah, so what other integrations were exciting and interesting to build, and yeah, that were cool? In fact, I'll ask, how does the emojis work, for example? Is that a plugin or something different?
No, that's not a plugin. So the emojis, we used an event that you can pass into IVS, which allows you to pass events of any kind of JSON object, and then we would render that event on the front end. And first of all, what we would do, we would just pass that event in and render it on the front end. But we found that it's really kind of addictive to hammer those emoji buttons and see them flying up on the page. But there's a limit on how many events IVS can handle. I think it was 5 per second, Dave, something like that.
I believe so, yeah.
So Eric can only get 5 thumbs per second. That's not
exactly.
That's a handful.
What it also meant was
I'll take it. It's not a handful.
a Lambda function for each individual emoji press, which was not a super efficient way of doing things, right? So we added a bit of resiliency and a bit of batching in there just by going from API gateway to SQS with a batch window of 5 seconds, or I think it was 5 seconds or 5 events. And so SQS would wait for either 5 events or 5 seconds to pass before passing everything onto a Lambda function, which would run all of, send all of those events onto IVS at the same time, rather than one Lambda function invocation for each individual event.
Okay. Yeah.
So we could batch up, we could stop our application from having to throttle itself, and we could save money because it was a more cost-effective way of using Lambda in that sense.
And I know, Eric, you were involved in building part of this as well, and part of the API integration with SQS is not running a Lambda function. So yeah, tell us about that.
Yeah, so and my headphones are, hear me okay?
Yep.
Okay, good. So yeah, so what's that? I'm sorry?
You sound funny because you're American anyway, and the three of us are in England.
So. Yeah, exactly. So Ben and Dave got to build the fun parts, like the emojis flying and stuff like that. I got to build the VTL, so which was actually fun for me. I'm that kind of nerd, and I'm actually going to try to share the screen for a minute to show what we're talking about. If you're not familiar with that, so let me bring this up here, hang on a sec. Window. All right, so we should be able to see that. Can you see that okay in there?
No, not yet. I'll add you in. Sorry, I think
alrighty, and we're
fighting each other.
So what you're looking at is this is velocity templating language, also known as VTL. And what this allows us to do is inside of API Gateway, we can do some transformations and even some logic before we ever hit the integration on the backside. Because of that, and because DynamoDB is an API endpoint, we can basically transform the request coming in, and we send it what you're actually looking at here is the response. Let me go to the request here. The request is usually something very simple like this, where it's just saying, hey, I'm going to grab some data out of that request. I'm going to put it in the format that DynamoDB expects. And I'm going to do some things like I'm looking for, you can see here on line 318, is there a specific key? This is pagination, kind of done in DynamoDB. And then the table name and the limit and the different things like that. And so it allows Dave's front end to send this information. It hits API Gateway. API Gateway transforms the request, inserts some things that we need, and then it sends it to DynamoDB. API Gateway handles the signing and the security of that for us. And then the DynamoDB then responds with a request. And then we take, and you can see we're doing some looping. We're doing all kinds of things going on. So we're checking for things. And you may look at that and go, wow, that's pretty complex. And in reality, it is. But what it allows us to do is be very agile, very quick. Now, I do VTL a lot, and people often say, are you anti-Lambda functions? I'm not at all. I think, I use Lambda all the time, Lambda functions. But I try to only use them when I need them. If I can transform this data at the API Gateway level, I don't have to invoke a Lambda at all, right, or a Lambda function. So this integrates again directly with DynamoDB, and we do a lot of different things with that. And I think the entire API is VTL. Yeah, I'm pretty sure Ben and Dave would send me and say, hey, we need this or that, and Ben did a lot. Yeah, I'm not going to take full credit. Ben did a lot of VTL, and Dave did some as well. So just another way of approaching API Gateway and approaching quick, agile applications. And the cool thing about VTL, the approach I do, and while it's hard, it's not for the faint of heart. When it works, it works. The kind of fun thing is it's kind of Boolean. It either just doesn't work or it works. And then when it works, it just works. It cruises really well. It's fast and reliable. So
if people want to learn some VTL, what resources would you point them to?
Oh man, so I've got a blog, and I'll grab it in just a minute, where I talk about building. We use a URL shortener, .com. And that is built using this same technology. It's API Gateway and DynamoDB. It was built as a proof of concept, and now a ton of people, we use it for reInvent, for everything we do. Anytime you see S12D as a link shortener, which you'll see in a minute, because I built the blog, I've got a blog that shows how to build that. As far as VTL on API Gateway, I would hit, we have the snippets on Serverless Land. It's got some VTL code examples in it, and there's patterns on Serverless Land that have VTL code in it.
Cool. Yeah, serverlessland.com. Yeah, go and look at the code stuff for information with that as well. But also, question, I know s12d.com. I don't know when that was built, but in terms of updates to that, of the actual code stuff, I mean, there hasn't been any update. There's no Lambda function, runtime going out of date or anything. That VTL has been there for years now, I think.
It has. Yeah, I wrote that, I believe, at the end of 21, or even earlier, maybe at the end of 20. I haven't touched it. Now, we're not going to show the front end of that because Eric's not a front end designer, and so it's not pretty. But as far as the back end, I've done some things. I've got some stuff in beta which is beta for you Americans. I've got some of that where I've got some like multi-level path going that I'm going to introduce later. But as far as issues, I've not had one. It makes me paranoid. I don't want to poke the bear, but it's run solid for years now without issue.
Cool. So that's a low code, very serverless approach of using a low code, it's non-Lambda code. It's configuration code rather than programming code to do a solution as well. Now, we did have an interesting question about architectures as well from one of our favorite countries and companies, Lego. Boomy Lol, thanks for joining us via Twitch. Thanks for joining us from Denmark. Want to build a serverless solution that delivers video on demand. So you're thinking of building a sort of similar-ish kind of application to specific authenticated users. You found an architecture that uses S3 and Lambda and Cognito and CloudFront and pre-signed US URLs. Is this a good approach? And the question I'm sort of asking is, there are obviously many different ways to kind of do this. How does one think about which solutions to use, and were there any lessons in the journey of building this that may be applicable to other people, navigating this kind of decision? It may not specifically be for serverless video, but in this example, it is.
Yeah. The first thing to accept is that there's many different ways of doing the same thing at AWS. Many services have features and functions that overlap. And it, I think, is important to try not to just go to the default thing that So for example, when we started this, before we wrote any code, we looked at different streaming services, different video services, Elemental, Kinesis video streams. And for various different reasons, which is a whole other talk, I suppose, we landed on IVS as being the ideal choice for what we needed, mostly because we wanted to build an event-driven app, and IVS integrates very nicely with EventBridge, and because it's Twitch is basically built on top of this IVS service, so we knew it would scale out very well as well. So all that to say, I would approach every new build by doing some basic research on what services are out there and what example code's out there, things like serverless patterns, before you even open up your IDE and start coding. Maybe that's an obvious thing to say, but I think sometimes we're under so much pressure to build things quickly that we sometimes forget to do some basic research on see what else is available.
Yeah, and all I'll add, and I'm just bringing up the question again from Boomy Lol. When you're building with a serverless approach as well, you can change things really, much quicker than you can in a traditional big architecture. So you can also try something and evolve it with far less cost and far less hassle with making some changes. Now, I don't want to be flippant and say there's not going to be hard work, but if you are using a serverless approach, there's a whole bunch of infrastructure you're not having to look after and do, so you can try some things and iterate. And even in terms of the iteration, this is a big sort of app. How long did it take to put this all together?
It took us about 2 months to build the core, and then another month or so to onboard all of the various plugins that were built by other developers. And I see there's a question about testing, which I'd like to talk about exactly how we did that, if that's all right. Can I share my screen again?
Yeah, sure. And Vinicius, thanks for joining us via YouTube and chiming in. We appreciate that.
Entire screen, yes. So we threw out to the track speakers of the serverless and the app integration track at AWS reInvent. We tasked them with the challenge of building a plugin for serverless video, and they met the challenge, right? They went away, they learned this event lifecycle architecture that we built. They built a plugin, and then they were asking us, okay, built my plugin. How do I know this is going to work? Like, I don't have access to your account, because we didn't want to share our core account. We wanted to make this, a realistic build that we see our customers doing. So how could we know that if we deployed something that one of our collaborators had built, how could we know that it worked? And we decided that, look, your plugin will run based on an inbound event payload. So here's what the payload would look like for each individual event hook. And this meant they could test it in their environment, right? And have it produce a result that they think would be valid, but we still didn't know that that would integrate when we run it and deployed it onto our own environment. So we decided to not only mock the payloads, but automate that using a step functions workflow, right? And this is what we did. We would have this workflow that would, as a sort of test harness, if you like, as a step functions workflow, it would emit the 4 different event payloads that exist in that event hook lifecycle, and it would check for various responses depending on which one of those payloads it emitted, and then it would return whether that was a successful or a failed plugin response. And so the first thing we had to do was to decide what are the characteristics of a serverless video plugin. Well, the first thing is that it had to be triggered by one of these 4 events that I went through earlier, but we'll call them A, B, C, and D. It had to have a rule that routed that event onto its starting invocation for that particular plugin. It then had to return something called a task token back to the bus. So a task token is what makes step functions pause at a given state. So step functions would emit that event along with the task token. Our plugin developers had to return that task token back to the bus when it had finished. Then we had to make sure that the format that it was responding with was a valid format, which we had documented for each type of event hook. And we had to make sure that it completed within the time constraints. It was 30 seconds, more or less, for each event hook. And so what we would do is we would take each plugin, which would consist of a deployable template. We would deploy that plugin onto our test account. We would run it against this workflow, and we would see if it would integrate. So for example, here's the moderation plugin. We would register that for event A, it would emit an event, it would return valid true. We would check that valid true is an okay response, and we knew that the moderation plugin would successfully integrate. We had so many plugins that were being submitted, this was too slow for us. So we decided to use GitHub Actions to automate this whole process, right? So what happens now is every time we had a plugin developer submit a pull request, that pull request would automatically deploy their plugin into a test environment along with the updated version of this testing workflow. It would then use the CLI to start that workflow, and then we would poll the workflow for a response, and we would either get running, succeeded, or failed, and then we would know by the end of that pull request if this would integrate or not. So what that meant is every day when we came back to our repository, we could see, oh, look, we've got a new pull request and it passed all the tests, and we can go ahead and deploy this into our staging account. And so that's how we were confident that any plugin would integrate if it had passed through this workflow.
Wow, I mean, that is amazing. I think the whole story of the double story of using step functions to do your testing and then automating that out of GitHub Actions is amazing. And I mean, Ben, you always say step functions first, step functions always. Like there are a lot of things that can be solved with step functions. And I think using step functions as a test runner in a way is amazing, because what are you doing? You asserting, you checking, you testing, you've got branching logic, inputs, outputs, all the kind of things, perfect for step functions. This is awesome.
It's good stuff, huh?
Yeah. So one of the other things I know, we had an earlier question on, which I know Ben chatted to in the chat, but it's partly about some of the tooling to build some of these solutions. Sorry, I know it's from Justin, and I'm trying to kind of see. Yeah, Justin, thanks for joining us and sticking around, hopefully via YouTube. And talking about, building things in the console or SAM and CDK and those kind of approaches. Now, I appreciate Dave and Ben, you sort of and Eric as well, you super experts on this as well. Oh, I nearly got into such bad trouble there. Super experts on this as well. And you have sort of opinionated kind of things. And I know, Ben, you also, said start in the console and everything. And I know Eric had some more information on this, but how do people think about the tooling and what to use and how to approach this?
Yeah, well, I would echo Ben. I mean, I would start there. Yeah, people start in the console to kind of just see what it does, and that's fine. But just like Ben said, we move out of the console as fast as possible. And the reason for that, it's okay. Why? If it works, why would I move out of the console? Well, the console is not manageable in the fact that, hey, I need to modify, I need to change this, I need to store versions of it. The minute I build something and I need Ben to be able to build it, I don't want to write down, okay, go here, go to this page, click here, fill that in, do that. I just want to be able to say, hey, deploy this application. And so that's why you want to get to IAC as fast as you can. Now, we're doing some things in the console. For instance, with the Lambda function, you can actually open up the SAM right there in the console. And then you can go to App Composer. And that's one of the things that I think, Ben, you mentioned that, yeah, in the text. Yeah. So we've done a lot of work around App Composer, and we're doing a lot more. But App Composer is tied to IAC. And when we say IAC, we mean infrastructure as code, right? So the person who asked the question is CDK, Terraform, we can name a ton of them, but we want to get to IAC as fast as we can. And with right now, and we hear debates all the time. Who's better, CDK or SAM? And to be honest, we actually figured out at reInvent last year, I won in the dance off, so SAM is better. But I don't know how to use that. Yes, Ben, you can look at me. I won that dance. So I don't know if that's really good data, but it was SAM against the otter. So but right now the App Composer works with SAM. You can use SAM to start it up. You can actually, and then from the App Composer, you can, because the question was specifically towards step functions, and for a long time it's like, well, workflow or step functions in SAM, we didn't work, and then we'd export the ASL, then we drop it into our CDK, or we drop it into our SAM. But now in the IDE with the latest AWS toolkit, you can open App Composer and open Workflow Studio from within App Composer, and it's all local in your IDE. Super powerful, a lot of work going on there. You can do it in the console as well. So I definitely, check that out. I don't know what, Dave, you're saying in the context there. Dave, you want to just say it out loud? Or
no, sorry, I just every word every so often you sound like a robot. That's why I put Eric.
Oh no, I'm sorry.
No,
okay,
okay. Most of it's okay. It's just every so often.
Okay, yeah.
That's good timing.
But no, yeah, I apologize. That's weird. But I know we have another question here, so I'll be quiet so you can look at that. But hopefully that helps. But so
yeah, but I still think that actually makes a nicer story, because previously we'd, when you're playing around, I mean, I build in the console. That's the kind of thing when you're learning and all that kind of thing, and you sort of get to a level where you want to progress, and that barrier to doing infrastructure of code is like, oh, now I need to refactor everything and redo it. And so with the Lambda with the Lambda function jumping to App Composer and step functions being able to jump to App Composer, it's actually so much easier now to just generate that infrastructure as code, that you're not caught out if you're not doing the right thing early, And yeah, I love that we're just able to more easily circle that. Plenty of comments coming in. We absolutely love the Bumil. Thanks for the feedback. And yeah, Robert Tables is thanks for joining us in on office hours. Sounds like my stomach growling. And yeah, definitely, as Ben says, you should see a doctor if your stomach growls like that as well. We do have a question which is sort of slightly different from Peru. Could be Paddington Bear, but maybe it's Rossi FNTO2 joining us from Twitch. We're gentlemen, which is very nice to hear. That obviously can't be me, so must be some of the others. But I suppose this is general guidance, documentation or a book that, has problems, and how do you, select which AWS solution? I don't know if there's a great answer for you on this, because there are many ways to skin a cat. But yeah, does anybody else have sort of places you can go to find some sort of use cases? Things I will talk about is we've got a bunch of serverless office hours that talk about various kind of use cases. I would, or let us know what your use case may be, and we can maybe give you a bit more information. But yeah, any other suggestions or? Well, there we go. Robert says just start serverlessland.com. So Robert, we appreciate that for being so kind to us. We'll give you a million free Lambda invocations every month. How does that suit? Yeah, Boomium, solutions arc. Yeah, that's actually a good point. I think once you start doing some of the certification things, that's also going to help you understand some of the services, and then I think they're going to be more apparent. Yeah.
Well, and you don't even need a cert for that. I hope I sound okay. Going for the cert, there's a lot of training that AWS provides to learn how to get that cert, and a lot of those questions are answered. Yeah.
And I think at least the most important thing we've taught people in this whole entire show that Ted the Toad says he didn't realize Paddington Bear was from Peru. So there you go. Marmalade sandwiches for
Go away with nothing. Go away with that.
So we've covered a lot. We've covered a lot. Maybe Dave, since you started to sort of wrap up, what were the learnings from this? Obviously, this is a demo application to do about video streaming, but if you can sort of wrap up with, the applicable learnings and the useful stuff that you could pick out of this, if you're building a video streaming app or any kind of application, how would this help you?
That's a good question. I think from my point of view, it's a great way, to be honest, it's a great way to kind of think about a problem and think about how the services can actually integrate together to solve your issue. We wanted to build a video streaming application. There are services out there to help us. And it's just about integrating all the services together to actually build this user experience. As I mentioned earlier, we've done it piece by piece. We kind of built on this core functionality. We exposed it as plugin architecture. So that worked really well for us. And just kind of a heads up here, we're actually working and talking at the moment about a workshop, a serverless video workshop that we're going to be working on this year. So if you actually see us at some summits maybe, or maybe at reInvent this year, we have to kind of dig out the details. But there's going to be a new workshop. So if you actually want to get hands-on doing this stuff yourself, we're building that now. Come along to that. But I'll hand over to Eric. What do you think?
Yeah, I'd say, as long as my voice is working here, start simple, work through your patterns as far as how you're going to communicate. Using the EDA, as we said over and over, using the EDA allows you to build in very small modules. I think sometimes we attack projects, I got to build the whole thing, right? And it's that old adage, how to eat an elephant one spoonful at a time or one bite at a time. And so you really chunks look at your whole thing, think in small chunks, use EDA to wire those together. And anytime you can use VTL because it's awesome.
Ben, last few seconds, anything to add?
Yeah, I would say use the services. Don't try and do it all yourself. Use the services as much as you can. Find out what they do and take away some of that stuff that you don't need to build yourself.
Yeah. Well, just for my kind of thing, we've got these 4 kind of things: the patterns, the workflows, snippets, repos, a whole bunch of code, a whole bunch of stuff that you can look at yourself. And yeah, our time's run out. Thanks. I think we've had a great fun time. It's so cool having the team together, talking about video and something we built, and a lot of time and effort and appreciation goes to the team for putting this all together at reInvent. And we'll see you around. Get in touch and say hi. We appreciate all the kind of things. We build it. If you've got ideas for future streams or future things, let us know. Thanks very much for joining us today. See you same time.